In this problem, 2.41, we have a Frisbee that's lodged in a tree. If this is ground level, then the Frisbee is located a distance h sub f above the ground. So that Frisbee's up here. Okay. A rock must be thrown, which must be moving at going at least 3 meters per second to dislodge the Frisbee. And what we want to know is how fast must the rock be thrown upwards if it leaves the thrower's hand 1.3 meters above the ground. So here is the point at which the rock is being thrown, okay, above the ground. So I'm going to call this location right here the origin, so that this rock must go up a distance y. Now the importance of using y is we have a kinematic equation involving y, and remember y is the distance above which you've chosen for the origin, okay? So obviously, oh, by the way, I'm going to call this h naught. Then the difference in those two values are y, okay? Now we're given that h of the Frisbee is equal to 6.5 meters, and h naught is equal to 1.3 meters. So the difference in those two will be the y value that we'll plug into our kinematic equation. Now this thing is thrown initially at velocity v naught, and that's what we're looking for, because we know it's got to be going a velocity v when it hits that Frisbee and knocks it out, okay? Now, probably it'd look better if v naught was a little bit bigger than v, because thing's going to lose some velocity. So I'm going to change the picture to kind of look like that, okay? All right, we're given that the final velocity must be equal to 3 meters per second. Now, you should know that a is equal to minus g, because I'm going to choose up as positive, and we know that the acceleration will be down. Okay, so these are all given. What we're looking for is v naught, and of course what we're looking for is some theory which will relate the given information up here to this v naught. Okay, so let's look for a theory. Okay, we know what y is. Okay, y is equal to h f minus h naught. Now we know the acceleration. We know the distance, y. We know the final value. All we need to find is initial value. Actually, there's one equation that'll solve that for us, okay? V squared equals V naught squared plus 2a, well, I'm not going to put the g in there, a times y. Now, all you have to do here is put it, now don't forget that minus sign right there. Put in a minus, that will be a minus 9.81 meters per second squared. Y will be equal to the difference in your two heights right here. And that final velocity is 3 meters per second. So you should be able to plug in the values here and get the value of V naught, okay? So I'll leave you with that to finish the problem, okay?